Now we're going to switch from satellite imagery to drones. We flew a drone over a second facility with a high-end camera and collected both images and videos. Let's take a quick look at how we can use this content in ArcGIS. Using one of our apps for the field, Drone2map, it allows us to process the imagery collected to create 2D and 3D products. These orange lines represent the flight path, and the blue points are the GPS locations of where images were captured. And for each of these locations, we can get to the individual images. Using these individual images, Drone2map has several processing options. For instance, we can do a rapid process to confirm that we capture what we expected while still in the field. And there are also different options for those creating those 2D and 3D products. Now, in less than 40 minutes, we had our first 2D product. Look at the rich detail of this orthomosaic. It was captured at 2 centimeter pixel resolution, as well as the high accuracy of our digital surface model and a digital terrain model. Now, once your products are created, Drone2map has options for you to share these to your organization as services, as well as to ArcGIS Pro. Switching to a 3D scene in ArcGIS Pro, we can continue to do our image exploitation and analysis. This beautiful imagery actually looks a little bit blurry, but there's a reason for that. You should have received a pair of anaglyph glasses, so let's put them on. Now, ArcGIS Pro can display in stereoscopic mode using either shutter or anaglyph glasses. So as we move around this scene, you should see additional depth and clarity using the glasses. Now, one of the 3D products that's created is a point cloud, like this one, which contains over 18 million points. And for each of the points, we can get to the X, Y, and elevation value. Drone2map also produces a 3D mesh. These 3D meshes give you a seamless, realistic view. For instance, I can even read the writing on the wall, AWT control building. Now, whether you're using a 3D mesh or a point cloud, you have the ability to measure distances and features. For example, the distance from the ground to the bottom of this vent is 3.1 meters. Next, we want to create a collection of stereo pair images to view in 3D. A stereo pair is 2 offset images that, when combined in the brain, give you 3D depth. As I zoom in on this building, we'll see the features pop out, like the pipes, the HVAC system, as well as this truck being filled. Now, as you move around in the stereo pair and get to an edge, you can simply hit the M key and it'll switch to the next best available pair. In this pair, there's a big pile of dirt, and I wonder where it came from. Feel free to remove your glasses as I switch back to a map to take a look at this area. It looks like they're doing some excavation. Let's compute the volume. Passing the terrain into this geoprocessing model that calculates volume, we can get the result for this area and see that it's 9,085 cubic meters. And these are just some of the capabilities of how these detailed drone products can be used in ArcGIS to do image exploitation. We would also like to give you a sneak peek of full motion video coming in Pro this summer. Videos captured with our drone will just be another data type that you can add to either your 2D or 3D view. Once these videos are added and we begin playback, you'll see information about the flight. For instance, where the drone was when the images were captured, as well as the footprint being captured at that time. Bookmarks are a way to navigate a map, but they're also a way to navigate your video. For instance, we can zoom to an area in this video and hit playback, and we can see the water movement in these aeration tanks. Now, if you see something of interest that you want to collect, you can simply edit and add features in the video or within the map. To close out our story, you've probably figured out it isn't another military facility in Iran at all. It's a water recycling plant in Southern California's Yucaipa Valley Water District. In a short amount of time, we were able to combine image and geospatial analysis in one common environment to investigate facilities in both Iran and California and gain complete understanding.